Imagine looking up at the night sky and realizing that one of those peaceful, glowing stars is actually swelling, trembling, and slowly dying. Not in a violent explosion yet, but in a dramatic transformation that will reshape everything around it. For the next few minutes, stay with me, because what I'm about to tell you will change the way you see the universe forever. This is the story of a red giant, one of the most breathtaking and terrifying phases a star can enter. And trust me, you'll want to watch until the very end. Because the final moments of a red giant's life are some of the most extreme events in the cosmos. They are born, they grow, they change, and eventually they die. And one of the most dramatic chapters in a star's life is when it becomes a red giant. If you've ever wondered what happens to a star before it explodes as a supernova, or what our own sun will eventually become, this is the moment you've been waiting for. A red giant is not just a bigger version of a normal star, it is a star in crisis. A star that has run out of the fuel it needs to stay stable. For most of its life, a star like our Sun burns hydrogen in its core. This nuclear fusion produces energy that pushes outward, perfectly balancing the inward pull of gravity. It's a cosmic tug-of-war that keeps the star stable for billions of years. But eventually, the hydrogen runs low. The core begins to shrink under its own weight. Gravity starts winning. And when gravity wins, the star changes. As the core contracts, it heats up dramatically. The outer layers of the star respond by expanding, swelling outward like a balloon being inflated from the inside. The star grows larger and larger, sometimes hundreds of times its original size. Its surface cools, turning a deep, glowing red. That's why we call it a red giant. It's not red because it's cold, but because its surface temperature drops as it expands. Imagine a star that once looked like a bright white or yellow point in the sky, suddenly becoming a massive bloated crimson sphere. It's still incredibly hot, but compared to its earlier life, it's cooler on the outside and hotter on the inside. Inside the core, something even more dramatic is happening. The star begins to fuse helium instead of hydrogen. Helium fusion requires much higher temperatures, and when it finally ignites, it can happen in a sudden burst called the helium flash. This is not an explosion that destroys the star, but it is a violent ignition that reshapes the core and stabilizes the star for a while. The red giant enters a new phase, burning helium into heavier elements like carbon and oxygen. These elements are the building blocks of planets, life, and everything we know. In a very real sense, red giants are factories that create the ingredients of the universe. But the red giant phase is not peaceful. The star becomes unstable. It pulsates. It sheds its outer layers into space. It loses mass. It becomes brighter and dimmer in cycles. Some red giants swell so large that if they replaced our Sun, their surface would reach all the way to Earth's orbit. That means Earth would be swallowed whole. And yes, that is exactly what will happen to our planet in about 5 billion years. The Sun will become a red giant, expand, and consume Mercury, Venus, and Earth. It's a slow, inevitable process written into the physics of stars. Now, before we go deeper, this is a perfect moment to remind you to like this video. Subscribe to the channel and hit the notification bell if you're enjoying this cosmic journey so far. We're only halfway through, and the most dramatic part of a red giant's life is still ahead. As the red giant continues to burn helium, the core becomes filled with carbon and oxygen. But eventually, even the helium runs out. The star is once again faced with a crisis. Gravity begins to crush the core further, but this time the star cannot ignite the next stage of fusion. The temperatures required to fuse carbon are far higher than what a star like our Sun can achieve, so the core collapses into a dense, hot, glowing ember called a white dwarf. Meanwhile, the outer layers of the star are blown away into space, forming a stunning, colorful shell of gas called a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. They are the last breath of a dying star illuminated by the white dwarf at the center. This is the fate of stars like our Sun. They become red giants, shed their outer layers, and leave behind a white dwarf. But what about stars much larger than the Sun? What happens when a massive star becomes a red supergiant? This is where things get truly explosive. Massive stars burn through their fuel much faster. When they become red supergiants, they are enormous, sometimes thousands of times larger than the Sun. Their cores become hot enough to fuse heavier and heavier elements, building an onion-like structure of layers. Hydrogen on the outside, helium beneath it. then carbon, oxygen, neon, magnesium, silicon, and finally, iron. Iron is the end of the road. Fusion stops at iron because it consumes energy instead of producing it. When the core fills with iron, the star is doomed. Gravity crushes the iron core in a fraction of a second. The core collapses, rebounds, and triggers one of the most powerful explosions in the universe: a supernova. The outer layers of the red supergiant are blasted into space at incredible speeds. The explosion is so bright that it can outshine an entire galaxy, and what remains at the center is either a neutron star or a black hole. So when we talk about red giants, we're not just talking about a phase in a star's life. We're talking about the moment when a star reveals its true nature. A moment when it transforms, expands, and prepares for its final act. A moment when the universe creates the elements that make planets, oceans, and living beings possible. Every atom of carbon in your body was once inside a red giant. Every atom of oxygen you breathe was forged in the heart of a dying star. You are literally made of stardust, and red giants are the cosmic furnaces that made that possible. Let's take a moment to imagine what it would look like if you were near a red giant. You would see a massive glowing sphere dominating the sky, stretching across a huge portion of your view. Its surface would ripple and pulse like a living creature. You would see gas being blown off into space, forming swirling clouds illuminated by the star's light. You would feel the heat from millions of kilometers away, and you would know that you were witnessing a star in its final majestic transformation. Red giants also play a crucial role in shaping galaxies. Their stellar winds enrich the interstellar medium with heavy elements. These elements later form new stars, new planets, and eventually, new life. Without red giants, the universe would be a much simpler, much emptier place. They are the cosmic recyclers that ensure the universe continues to evolve. Now, as we approach the end of this video, I want to ask you something. What surprised you the most about red giants? Was it the fact that our sun will become one? Was it the idea that red giants create the elements inside your body? Or was it the explosive fate of massive stars that become red supergiants? Let me know in the comments, because I love hearing your thoughts and seeing what fascinates you most about the universe. And before we wrap up, if you enjoyed this journey through the life of a red giant, make sure to like the video, subscribe to the channel, and turn on the notification bell so you don't miss any future explorations. We've only scratched the surface of the cosmos, and there are countless mysteries waiting to be uncovered. Your support helps this channel grow and allows us to dive deeper into the wonders of space. Thank you for watching all the way to the end. You've just learned how stars transform, how they create the elements of life, and how they die in spectacular fashion. The next time you look up at the night sky, remember that every star has a story. And some of the most dramatic stories begin when a star becomes a red giant.